So what I'm going to do now is introduce you to the idea of a rational function. Now a rational is anything that can be written as a fraction. So 2 would be a rational number because it's really just 2 over 1. A third is a rational number because it's 1 over 3. So now if we look at the idea of a rational function, we're going to have a fraction that has variables on top and the bottom at the same time. So the first thing though is to remember that when you're looking at any fraction, the denominator, which is just math speak for the bottom, can never equal 0. Because rationals or fractions represent a division, and dividing by 0 is an impossible question, because dividing means how many groups. So if I look at 12 divided by 0, that means how many groups of 0 does it take to get 12? Well, there's no answer to that, because no matter how many groups of 0 you still have 0. So dividing by 0 represents an impossible thing. So we are going to have restrictions based on the fact that the denominator or bottom can't be 0. And restriction just means what can the letter not be. So let's look at some examples that will hopefully help this. So if I have 6x squared plus 2 all over 5x. This is definitely a rational function because I have a function on top and a function on bottom, and this represents a divide. Well, I'm not going to do anything with this yet except just state the restriction. If I look at the bottom is 5x. Well, 5x cannot equal 0. So how we showed cannot equal 0 is the equal with the slash through it. Well, if I look at this, that means x can't be 0 because 5 times 0 would be 0. Or you can think of the 5 as being multiplication here. If I move it to the other side, I'm going to divide. 0 divided by 5 is still 0. So for this question, if we just want to state the restrictions or what x cannot be, the restriction would be x can't be 0. So if we look at another one, and again for this question, all we want to do is state restrictions. Well, here's the difference. Now I have a quadratic on the bottom. So in order to solve to figure out what would make it equal to 0, in order to figure out my restrictions, I have to factor. So I'm going to say, well, x squared minus 9 can equal 0. That's a difference of squares. Here's where the factoring we reviewed at the beginning of the course is going to become very important again. That x squared minus 9 factors to x plus 3, x minus 3. So my zeros would be x equal to 3 and x equal to negative 3 from the first bracket, x equal to 3 from the second bracket, but because now I'm talking about restrictions, it's x can't be those values, because if I put positive or negative 3 back into this original bottom, I will get 0. So for the first two questions, we were just looking for restrictions and we found them. So if the question just says state the restrictions, you're just trying to figure out what values would make the bottom equal to 0. But now we're going to look at simplifying these things as well. And simplifying is the same as if we were working with just normal fractions that had numbers on top and bottom instead of fractions. It means we're going to reduce to lowest terms. It's going to be a little strange because we're not going to be working with numbers, we're going to be working with actual functions, but we're going to reduce to lowest terms, but you always have to state any restrictions. So example 3, now we're not just going to state restrictions, we're going to simplify. And a lot of the times the variable we work with will be x, but it could be any letter. In this case, it's k. Well, whenever you want to simplify, you really want to factor the top and the bottom. The top here is a difference of squares, so it's going to factor to k plus 2, k minus 2. Remember, the order of the bracket isn't important. Unfortunately, this bottom here, I have to do decomposition because there is a number in front of the k squared. So I could do decomposition and rewrite the question over and over again. I'm actually going to factor it though just off to the side and then put my answer there to save myself some time. So for decomposition, I do 3, which is the number in front, times -2, which gives me -6. I'm looking for two numbers that multiply to give me -6 and add to give me the middle number, +5. So it's going to be +6 and -1. I'm going to take +6 and -1 and use it to decompose or rot the +5k. So now I have 3k squared plus 6k minus 1k minus 2. I'm going to common factor the first two. 3 and k are both common, so I'm going to get k plus 2. The only thing common here is a -1, but when I take it out, I get k plus 2. I know I'm right because my brackets are the same, so one bracket is k plus 2 and the other bracket is 3k minus 1. So now that I have the bottom factored, I'm going to bring my factors and write them for the bottom. So now instead of k squared minus 4 over 3k squared plus 5k minus 2, I have it factored to k plus 2, k minus 2 over k plus 2 and 3k minus 1. The thing you have to remember is that you always have to factor before reducing. I can't start looking over here and say there's a k squared and there's a k squared. You can't cancel when there's adding and subtracting. It has to be written as a product. But now I have a k plus 2 on the top and a k plus 2 on the bottom. So I'm really going to divide the top and the bottom by k plus 2, which gets rid of it. It's kind of like having 2 over 4, dividing the top and the bottom by 2 to get 1 over 2. I have bracket on top, bracket on the bottom, so I divide by that bracket, and my final answer is k minus 2 over 3k minus 1. I don't need the brackets because there's nothing else, but there's absolutely nothing wrong with keeping the brackets. So now we've reduced it to lowest terms. But now we have to state any restriction. So after my answer, I'm going to put a comma, and I'm going to give my restrictions. The restrictions come from the bottom, and even though this k plus 2 bracket is gone, I've actually divided by that bracket. So in a way, it's even more important that this bracket is not 0, because I have actually divided by it. So you go up to where all of your pieces of the bottom were, and I'm going to give my zeros. The solution, or the 0 from k plus 2, would be -2. So that gives me my first restriction. K can't be -2. If I look at 3k minus 1, if I solve this equal to 0, I'd have +1 over 3. Or remember, we talked about the short form opposite over, and because that's the 0, that is my restriction, +1 over 3. You can list them once after k with just a comma in between them. So there's the final answer. I've reduced it to lowest term, so it's gotten smaller, and I've said what the bottom can't be. Let's do another example of that. So 3x minus 12 over x squared minus x minus 12. So this one's actually a little bit nicer than example 3 because the top isn't a quadratic, but I can common factor out a 3. So I get 3 and then x minus 4. The bottom is a quadratic, but because there's no number in front of the x squared, I can go right to bracket, 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 bracket. I'm looking for two numbers that multiply to give -12 and add to give -1. So that's -4 and +3. I can't reduce the 12s here even though they look the same because that's reducing around and adding or subtracting. Can't do that and maintain equality. It has to be written as a multiplication. But now I can cancel the x minus 4 brackets, and I'm left with 3 over x plus 3, with or without the bracket on the bottom. Not a problem to leave it, comma, as long as x is not. And I'm going to go back and say, okay, the 0 from this first bracket, even though I got rid of it, I have to take it into account, would be 4. And the restriction, or the 0, out of the second bracket would be -3. So it's factor, cancel, and then state any restrictions. The restrictions come from the zeros of the bottom, and don't forget to account for restrictions from any of the quantities that you have canceled. So the homework is the same for both the U's and the M's. I want you to take a look at the questions starting on page 353, and I want you to do number 1, number 5, and number 8 as best you can for tomorrow, and we can go over any questions after that.